In this video, we're going to talk about some review for our quadratic functions unit. So we're going to touch on some key characteristics of a quadratic function graph. We're going to talk about the three different forms of an equation for a quadratic function, what we can take from those different equations, and how to find the other key parts of our graph based on the form we're given. In another video, we'll do some review on how to solve for the roots of a quadratic using complete the square and the quadratic formula methods, as well as how to simplify radicals. So first, let's start with characteristics of a quadratic function. So looking at our graph, there are a few key points that we need to know in one line. So we should know how to figure out if our graph opens up or down and what our x and y intercepts are, as well as the vertex. And our vertex goes along with if our graph opens up or down. So those are connected there, and also tells us if we have a maximum or a minimum value. And then we also have our axis of symmetry, which goes through our vertex. So looking at our graph, if we're given a graph, we can identify all these points. If we're given an equation, we have to do a little bit of work to find those points. So in this example here, we've got our vertex. Remember, that's the middle or kind of the starting point of our graph. And we've got our axis of symmetry that cuts right through it. Remember that axis of symmetry, axis means line, symmetry tells us that our graph is symmetrical. It's the same on both sides, where it's just kind of reflected across that line. So any point on a graph is going to be equidistant from another point reflected across that axis of symmetry. And then we've got our x-intercepts here and y-intercept. So the vertex, like we said, it either has a maximum or minimum. Well, if our graph opens up, like the example you see here, our vertex is a minimum. The graph doesn't go any lower, so that's the minimum point. And so when we're talking about maximum and minimum, it's really talking about the y values of our graph. If our graph opens down, then our vertex is the very top of our graph, and so that is our maximum value. Okay. Some other key points to know about our graphs here is that the x-intercepts, oftentimes we see examples where we have two x-intercepts, but it's common for you to see examples where we have 0 or 1 x-intercept. Remember that x-intercepts are also called a root or a 0. And the y value is always 0 for those x-intercepts. For the y-intercept, the x value is always 0. And in these cases with a quadratic, we're only going to have one y-intercept. Okay? If we have more than one, or we don't have any, then it's no longer a quadratic function. Okay? Our three forms of a quadratic, you may be familiar with some more than others. We've got our standard form, which is also referred to as general form. Okay, that's ax squared plus bx plus c. The a, b, and c value are all important in their own way, and we'll see why that is and how we can use those values to get certain parts of our graph. We've got vertex form, which gives us the vertex of our graph, and then factored form tells us our roots. Notice how each form has a different number of parentheses in them. And so that's one way you can quickly identify which form you're given. So let's look at some examples here. Our first example is y equals x minus 3 times x plus 5. I see two sets of parentheses, so that tells me that that is in factored form. Okay, so each of these binomials here, x minus 3 and x plus 5, tell us the roots or x-intercepts. Okay. And then no matter what form we're given, we can always identify whether it's open up or down. You notice in each of these forms, we've got an a value at the very beginning of our equation. If that a value is positive, then it opens up. If a is negative, it opens down. So if you think about transformations with any function, if you multiply by a negative in front, that reflects your graph down. So because we have no number out in front, that there's a 1, positive 1 there, so a equals 1, so then this one opens up. Example 2, y equals 2x squared plus 8x minus 6. There are no parentheses there, so that tells me that is standard or general form. Okay, looking back here, the c value that's given, that tells us our y-intercept on our graph. Okay, so our y-intercept in this graph would be negative 6. The first number here, 2, that's our a value, and it's a positive 2. So again, we open up with this graph. Third form, there's just one set of parentheses, and it has to have that squared right up or to the outside of our parentheses. So that tells us it's vertex form. And the reason why it's given that name is because it tells us the vertex of our graph. Number in front of our equation is a negative 3, and so since it's negative, this case, it opens down. So now let's get into an example of each form and how we can find the different parts of our graph and put that graph together. So again, I've got factored form here, 2 sets of parentheses. And anytime you see anything in parentheses here, whatever that gives you about the graph, the numbers or what you're doing there is opposite on the graph. So if it says x minus 4, then that means on the graph, we have an x-intercept of positive 4. And we have x plus 2. So the opposite is negative 2. I'm going to go ahead and put our x-intercepts in there, 4 and negative 2. Right? Now our axis of symmetry, remember that's halfway between our roots. It goes right through the middle of our graph. So since I already have these 2 points graphed out, you can just count out and figure out where the middle of that is. You can also take your 2 roots, 4, in this case negative 2, and then just add them together, divide by 2. So you're finding the average. And we end up with 1. I'm going to put a dashed line there for that because it's not actually part of our graph. So that dashed line just shows us that it's giving us a reference point for our graph. Now our vertex. We know that our vertex is on our axis of symmetry. And so since the axis of symmetry, which we should write as x equals 1, that tells us that our x value is 1 in our vertex. And anytime we have an x or a y value, we can plug that into our equation to find the other half of our ordered pair. So if we know that x equals 1, substitute that in to our equation. We get y equals negative 3 times positive 3. So the y value of our vertex is going to be negative 9. Now I don't have a lot of room here to count out 5 more spots to get down to negative 9. So I'm just going to put a little little ways below, and then just label that specific point. Okay, so even though my graph may not look perfect, at least it's labeled correctly. And then the only other thing we need here is our y-intercept. Okay, and I know that my y-intercept always has an x value of 0. So similar to how I found my vertex, I'm taking the part of my ordered pair that I know and substituting that in. So if my x value is 0, then I get -4 times a +2. We get -8. And so that's going to be just above where my vertex is. And again, this looks like I can't accurately put in the tick marks there, so I'm just going to label that as -8. And now from my vertex, I'm going to go up and to the left, up and to the right, and get my U-shaped parabola. All right, next example, I've got no parentheses there. This looks like ax squared plus bx plus c. So this is standard form. Okay. Now I like to label off to the side here what my a, b, and c values are. Okay, so we get 2, -6, and 3. Our y-intercept, that's given. That's this 3 value, or the c on our graph. So I get 0, 3. Now the axis of symmetry, we have to remember in standard form, this is where a and b are useful. We use that in this formula, -b over 2a, to figure out our axis of symmetry. So if I have -b over 2 times a, now I just plug in a and b. B is already negative, so now that's going to become a +6 over 4. If I simplify that, I get 3 over 2, or 1.5. Our vertex, again, it needs that same value, 3 over 2, or 1.5. And so we're going to plug that into our equation here. If you're using a calculator to find this, it might be easier to use the decimal. So here we end up with 4.5 minus 9 plus 3. We're going to have a negative 1.5, or 3 over 2. And in this case, we would have a little bit of work for us to do the x-intercept. So we're just going to check the graph and see what we've got here. Just check that we've got our y-intercept of 3. That looks good. And then our vertex is here halfway between 1 and 2. And down here halfway between 1 and 2. So that matches what we found there. If you can easily factor the equation, do that and use that to find your roots. It looks like in this case, they're going to be decimals that aren't going to be nice numbers. So again, this example would be a little hard to factor. Last example here, we've got vertex form. Again, in the parentheses, that's opposite, so it's going to be a +1, and then the y value is here, and that's the same, so that's +8. Our axis of symmetry is going to be x equals 1. We're going to plug in 0 for x And once we figure all that out, we end up with